All right. So what we're gonna do is we're gonna start with the antiderivative and indefinite integrations. So I'm gonna go a little bit faster because I missed like 2 minutes, 3 minutes. Um, so dy dx is equal to 2. Um, so can you tell me what is the original function of y? What do you think y is if dy dx is equal to 2? 2x. Yeah. So you know that y is equal to 2x, except that's not correct. But it's not incorrect either. What is missing?
You don't know
There's a constant. Why does a constant matter? Because if you take a derivative of a constant, it's still going to go to 0. And if you take a derivative of 2x, it's still going to give me 2. So any type of constant. So it could be 2x plus 1, 2x plus 10, 2x plus 20, 2x plus pi, 2x minus pi. Those are really important because that if you take a derivative of 2x plus anything, it's always going to give me 2. So we're going to name this called a constant of integrations. Now, it's super important you write this down because if it's a test, it's a 10-point test. If you without plus c, that's going to give you 5 points. So almost not worth it to just not forgetting the c. Very, very important. Now, this is called a particular solutions. This is called, no, sorry, general solution. Sorry, general solutions. The operation from here to here is called the antiderivative. It's antiderivative or definite integral, indefinite integral. Indefinite integration. So the process from the dy dx to y is called antiderivative. Now, what is the function called before you take an antiderivative? What is this function called? This is called a differential equation. Is this okay? So that means, well, how do we do the antiderivative? What's the notation? Some people say it's like a squiggle line. Yes. So this squiggle line here looks like this. F prime of x dx. So if you take an integration of f prime of x, it becomes the f without prime. Become the original functions. Is this okay so far? Okay. Now let's talk about some basic rule about derivative. But why do we talk about derivative first? Because if I take a derivative of a constant, it's going to give me 0. Derivative of constant is going to give me 0. How about integration of a 0? That should equal to a constant. If I take a derivative of kx is equal to what? K. What's integration of k k dx? Kx plus c. Is that okay? How about d to the dx of kf of x? Well, that becomes the k can be outside, so be kf prime of x. What's integration of kf of x? Again, you can take a k outside, f of x dx. Okay, I just take integration by taking the k outside. So constant can become an outside. Now realize that all this rule is important because your first questions on your homework could be involved with something like as simple as this. And 60% of you guys will get it wrong, even though it's super simple. Okay, so very, very important. All this rule are very important. How about if you take a derivative of f of x plus minus g of x? Well, that's equal to f prime of x plus minus g prime of x. It's kind of distribution, kind of like distribution. Integration of f of x plus minus g of x dx, that's equal to integration of f of x dx plus minus integration of g of x dx. And this is a very simple idea because you take a derivative of two separate terms, just take a derivative of each individual term first. If you integrate on two separate terms, you take an integral on separate term as well. Yes?
No prime on the other side.
No. Now, lastly, we would like to talk about this, which is we know as a power rule. How do I take a derivative of x to the n? There you go. But this is a derivative. But how do I take integration of x to the n? Right? So this becomes a very critical. You say, okay, let's take an integration of this. So what I'm trying to say is, what happens if you have x to the 5? What thing you take a derivative is going to give you x to the 5? Can you imagine a function you take a derivative is going to give you x to the 5? So let's just say if dy dx is equal to x to the 5, what will be y? What will be y? Okay, Max, what you say? 1/6x to 6, right? Because if you take a derivative of the 6, the 6 comes down. 6 and 1/6 cancel out, and the 6 minus 1 becomes a 5, right? So can we use this to create a rule for x to the n? So what will be x to the what? N plus 1 over what? Don't forget the plus c. N plus 1. And if you don't believe me, let's take a derivative of this. Let's just say, hey, let's take a derivative of this. X to the n plus 1 over n plus 1. Plus c, of course. If you take a derivative of c, it's 0, right? If you take a derivative of x to n plus 1, guess what? N plus 1 put in the front, right? Over n plus 1, right? And this one's x to the n plus 1 minus 1, right? So that's cancel out. That becomes x to the n. Right? If I take a derivative of the power rule, it comes back to before. So basically, you just take integration x to the n, becomes x to the n plus 1 over n plus 1 plus c. Very, very simple rules. Any questions so far? All right. Now what we're gonna do is we're gonna integrate something. We're gonna integrate something called 3x dx. First thing that we're gonna use is a constant multiple rule. The constant multiple rule says this 3 can be taken outside. So it'll be 3 times x to the 1 dx. Is that okay? How do I take the integration of x to the 1? Using power rule. Now remember, this one just becomes 3x to 1 plus 1. Is that okay? Over 1 plus 1 plus c. So that's going to be 3x to the 2 over 2 plus c. And that's integration. Anybody can do this. A pre-algebra student can do this. It just follows the rules. However, what pre-algebra student usually not weak on is the exponent rules. Exponent rule is something that you're going to be used a lot more than the actually power rule. So all those rules is very, very important. So in your algebra 1, you learn about all this rule of pre-algebra. This rule is going to use a lot more than the power rule because all the thing is going to be anything to the 0 is equal to 1. Now, especially this rule, you're going to use a lot. A to the negative n equal to 1 over a to the n, or a to the negative n equal to a to the n over 1. A to the m to the n power is equal to a to the m times n. The last rule we're going to use a lot as well is a to the m n equal to a to the m over n. It's called definition of radical. So you're going to use all those rules more than the power rule, honestly. So you have to be expert at exponent rules. Yes. It froze again. Damn it. I try my best, but people just need to show up to school. When did I froze?
They just
Oh, great.
for this question.
I just need I need to reset my whole computer. The problem is that I think my internal memory is too small now, so that's why it doesn't last. And that's why it froze, because my internal memory is, and I don't know how to do it unless I reset the whole computer.
You can say and ask.
Okay, so the exponent rule is very important. So now I want you to take an integral of this. How do I take an integral of this? 2 over x to the cube. Two over x to the cube. So you can't really take an integration of this as right now, right? Because it doesn't really fit to power rule. The power rule is x to the n. It's x to the n's on numerator. So therefore, it's going to be 2. We're going to use the algebra rule. Says, hey, let's change this to -3. Did you guys do this first? Because you can't really take integration of those right now. Okay, so now if we integrate this, it's going to be integration of -3 plus 2 over -3 plus 2 times 2 plus c. Oh, plus 1, sorry, plus 1. My bad. So it's going to be 2x to the -2 over -2 plus c. And that's 2 and 2 cancel out. That's going to be -1 over x squared plus c. Is that okay? Yes.
So is dx is always a constant, it just goes plus c.
What do you mean dx? Dx is the differential. If you take an integrate, it'll go away. No, it's not, because that's not why it becomes c. Dx is small changing over x. But if you take an integration of dy, it's going to give you y. Integration of dx is going to be x. Any questions here? No. Okay, so how about integration of 1 over x to the third, like this? So if I integrate this, that's going to be x. Well, this one's going to be -3 over 2. Did you do that? I haven't taken integral yet. I just changed that to -3 over 2. Why do I know that? Because that means 1 over x to 3 over 2 dx. And if I move to the top, it becomes -3 over 2. Is that okay? So if I integrate this, it's going to be x to the -3 over 2 plus 1 over -3 over 2 plus 1 plus c. Now that's going to be x to the -1/2 over -1/2 plus c. -1/2, that means divide. So that's x to the -1/2 divided by -1/2. So that means x to the -1/2 times 2 over -1. So therefore, it's going to be -2x to the -1/2 plus c. Don't forget the plus c, or -2 over square root x plus c. This is my final answer. Again, it's people need to be expertise at exponent rule in order to do well in calculus. Most of people struggle is all the basic algebra. Okay, let's try it. Sure. Now let's put in mind, the power rule is the only rule for integration. There's no other rule. There's no chain rule. There's no quotient rule. There's no product rule. There's no other rule except power rule. You have to make sure you convert to where its power rule makes sense. So that means a lot more algebra manipulations. How do I change this to strictly power rule? What's the best way to do this? Can I expand? Of course. Okay, let's expand the top, because the only thing I know that I can say, hey, let me expand the top. So it'll be 3x plus 2 over 3x plus 2 over square root x dx. Am I going too fast? I didn't do anything crazy. I only just write it twice so I don't kill a puppy. Which is most of you guys want to think that's 9x squared plus 4. That's not correct. Well, some of you guys recognize that. I can expand this, so that's going to be 9x squared plus 12x plus 4 over square root x dx. Did I do anything that's out of line that you don't know how to do? What can I do here? Is any quotient rule for integrations? No, but if I were to take a derivative, how would I take a derivative? If I were to take a derivative. Who says split up? Good. You split up each individual term. So that's going to be 9x squared over x to the 1/2 plus 12x over x to the 1/2 plus 4x to the 1/2 dx. Do you realize I haven't used calculus yet? It's pretty much just algebra. You manipulate algebra until you can use power rule. So that here it's going to be 9x to the 3 over 2 plus 12x to the 1/2 plus 4x to the negative 1/2 dx. Have I used calculus yet? No. The only time I'm using calculus is right now, which is I'm going to integrate this. Don't let it think that's the calculus. No, that's why I keep an integration sign there the whole time. Until now, I'm going to write in red. It's going to be x to the 5 over 2. 9. Now, I know it's 5 over 2 divided by 5 over 2. That means same things times 2 over 5, right? So I'm going to write down 2 over 5 like this. Is that okay? Is that okay? Because I know divided by 5 over 2 is same things times 2 over 5. So I write in the front. Yes.
Wait, where'd you get 5 over 2?
Remember, it's 9x to the 3 over 2. If you integrate this, it's going to be x to the 5 over 2 over 5 over 2, right? And if you keep change flip, so that's going to be x to the 5 over 2 divided by 5 over 2, which is 9x to the 5 over 2 times 2 over 5. So that's why 2 over 5 is there. So I just do it in one step because I want to save some writing. Are we okay here? Plus 12x to the 3 over 2. 12 times what? 2 over 3. Plus 4x to the 1/2 times what? 2. And then that's equal to 18 over 5x to the 5 over 2. Plus this one cancel out. That is going to give you 8x to the 3 over 2 plus 8x to the 1/2 plus c. Is that okay? I didn't do anything crazy. Now the only thing I use calculus is this part. Everything else is algebra. That's why a good algebra 1 student, if you give it to me, a good algebra 1 student, I can train you to calculus. The problem is most of you guys struggle here and there with algebra. If you don't struggle here and there, you should not struggle in calculus. Everything should be a breeze. All right, I'm going to give you one. Fabian still recording or no? Remember, it's all exponent rules. That's why a lot of people, like, after they take calculus, they find out the SAT improve. It's like you doing small minor part of the SAT. The exponent rules, the factorings, the distributings. You had to do all the algebra before you do calculus. Hmm. Is this right? Yeah.
Do you need to, for the one where it's negative 50x to the power of negative 1/2, wouldn't you put you put the x on the bottom for that one?
You can, you don't have to, but you can. So this one can says
Negative 50 over.
it's okay. Either one is fine. Is that hard? It's more algebra, like I said, it's more algebra. If you're good at exponent rule, then you should be good. Okay, any questions here so far? If you got this, you're doing great. Now I'm going to talk about what's the difference between particular solution and general solution. Yes.
You get 25x negative 3.
Because the x times square root x is equal to x times x to the 1/2. That becomes x to 1 plus 1/2 is 3 over 2. Did you do that? Okay. So then you got 25 over x to the 3 over 2. That becomes 25x to the negative 3 over 2 if I change your numerator. Does that make sense?
Yeah.
Anybody else have any questions? Okay, so the next thing is we're going to talk about what's the difference between particular solution and general solution. Now, understand that calculus integration is only a power rule. There is no other rule. There's no chain rule. Please don't do something like chain rule for integration or like anything like that. It will be stupid. Okay, so let's talk about if today I have a dy dx is equal to 3x squared minus 1. Not only that, we have an initial condition. What is the initial condition? We're going to talk about what's the initial condition. you're gonna hear that term a lot. Initial condition is 2 comma 4. That means if I take an integrate of this, I'm gonna have some type of plus c, which is a vertical translation. That vertical translation, there's only one situation it's gonna touch 2 comma 4. I'm gonna explain that in a second. So how do I find out the y? What do I supposed to do? You what? Antiderivative, right? So what we're gonna do is we're gonna show you another thing that's gonna give you one extra point on separation variable on the in terms of FRQ is to separate a variable. So what I mean by that is times dx on both sides. It looks like that. And what I'm gonna do is I'm gonna integrate this. Now what's integrated dy? It's just y, which is that's the original function. Integration of 3x squared is gonna be x cubed, right? Minus x. That's it. Is that right? And minus 5.
You have the plus c.
You have to have a plus c. If you don't have plus c, you're gonna have 5 points off. I'm gonna explain to you why you have 5 points off now. This is known as the general solutions, but it's not a particular solution. What does that mean? That means if I go to graph, this is the graph. But do you see that point? 2 comma 4? There's only one situation when this graph that going through the 2 comma 4, which is in this case is going to be negative 2. But you had to find out where the negative 2 is. How do we find out? We have initial conditions 2 comma 4, so we can put 4 in here and put 2 in the other side because that's the x. This is the y, right? Just plug in. 4 equal to 8 minus 2 plus c. 4 equal to 6 plus c. C is equal to negative 2. And guess what? Y equal to x cubed minus x minus 2 is called a particular solution. And this particular solution is based on the initial condition 2 comma 4. Because 2 comma 4 is a point. It must go through that point. The only way to get through that point is to find out the value of c. You can try one. Now this is the exact same thing, but it's different expression. So hopefully you understand what I'm saying. F prime of x, capital F prime of x is equal to 1 over x squared, and f of 1 is equal to 0. So what is this actually meaning? The same thing as before. This means this is the same thing as dy dx, right? This means 1 comma 0, right? Initial condition. It means exactly the same. It's just different expressions. So what do I have to do with 1 over x squared? I have to take an integral. How do I take an integral? I'm going to change to negative 2. And that's going to be x to the negative 2 plus 1 over negative 2 plus 1. That's going to be x to the negative 1 over negative 1 plus c. That means equal to negative 1 over x plus c. that becomes f of x. And they say 0 is equal to -1/1 plus c. C is equal to 1. So guess what? This is a particular solution. Is that okay? Fairly easy, right? How many of you guys are lost? Let me know. All right, I'm gonna give you a question that's a little bit harder. Now I'm gonna give you two initial conditions. Okay, two initial conditions. It turns out there's two c's here. You had to find the first c, and you're gonna use that c to take an integral. And then you have to, after you take an integral, then you have to find out the second c. So there's two c. Because we start with a second derivative. So there's two layers. Each layer has its own c. Does that make sense or not? Do you see what I'm saying? So that means if I integrate 3x squared dx, which is something fairly easy, is equal to x cubed plus c, right? That's equal to x cubed plus c, and that's equal to f prime of x. Is that okay? Now I'm going to use the first initial condition because this initial condition is based on f prime of x. So that is equal to -2 equal to -1 to the third plus c. -2 equal to what? -1 plus c. C equal to -1, I think. So that means f prime of x is equal to x cubed minus 1. You had to base on this new c to take an integral. You cannot just say plus c and integration of plus c cx. No, you're going to base on the c first because we use the first initial conditions. Next one, we're going to try to get to here. That means I need to take an integral again, but this time there's no plus c because we already found out what a c is using the first initial condition. So that's going to be x to the 4th over 4th minus x plus c. This becomes f of x. Is that okay? And then f of x is equal to x4. Oh, then you can plug in 3 equal to 2 to the 4th over 4 minus 2 plus c. 3 equal to 4 minus 2 plus c. 3 equal to 2 plus c. C is equal to 1. So therefore f of x is equal to x to the 4th over 4 minus x plus 1. Because I used the first c. How much time I have? 2 minutes? Okay, so I'm gonna give you one. F of x, f double prime of x is equal to x to the -3 over 2. -3 over 2. And f of prime of 4 is equal to 2. F of 0 is equal to 0. So I want you to find out original equation is.
On the right, what is that number? F of
f double prime of x is equal to x to the negative derivative 2. F prime of x, f prime of 4 is equal to 2. That looked like an x.
What is that 0 is equal to 0?
Yeah.
Okay.
Maybe it's still recording or no?
Yeah.
Equal to 1? Oh, this is negative 2?
Be negative 2x. Then if we write it equals 3. 3 and 3. What? Either. I got 3 and 3. Okay, then you get for your equation negative 4x is 1/2 plus 3x plus 0.
Negative?
Yeah.
4?
Negative 4x is 1/2
Yeah.
plus 3x
I know, I saw.
plus 0. Because our c is equal to 0. Oh, yeah, you did it. So it's c equals 0. I like to use it a lot.
I don't care. You guys, you need to know things that there is a priority. I cannot just because I have to keep. You always have same thing. You always have extra thing you have to do, but you're not treating this class like a priority. If you're not treating this class as a priority, I already give you opportunity. I know you have accident. I feel bad for you, but you come back, you need to make up the things. You cannot just say, oh, I have this priority that I do. Well, I have priority too. I have priority of all the student I had to pass the test back to. and just because you have to delay a pass back a test a day, that doesn't make sense to me. So the problem of you always have the same issue. You have attendance issue. This time it's not your fault, but in the past it's your fault. Homework, there was homework issue, and your basic algebra is not good. And you are supposed to go into you're supposed to ask Gabby to help you, but you did not ask Gabby to help you. You asked Gabby at the last 2 days of the Thanksgiving. You should have asked before the Thanksgiving.
Actually, I did text her before we had the test as well, but she doesn't read my message. She didn't see. She
Of course she
didn't see the
doesn't.
message.
Well, your parents supposed to call her and they're supposed to ask her to help you, and you're supposed to help her. She's not gonna do it for free. Sometimes she would actually, but the problem is your parents supposed to contact her. You're supposed to contact her way before that, not before the day before the test too. I give you a number way before that too. But you guys only ask, oh, let me ask you the day before the test. Of course, that's not gonna work. That's just not how it works. You are struggling with basic things. Adding fractions, multiplying fractions, even today's stuff. I don't know if you get today's stuff. I have no idea. But a lot of things is that you're missing the basic information and you never tried to learn that before. And that's what it's like a snowball effect. It's keep on going and going and going. If you didn't know how to add fraction the first 9 weeks, you're supposed to learn it try to learn the first day. Try to learn the second day, try to learn the second week, third week, 4 weeks. Now you still have some issue. Now still ask you, sometimes you have a question like, wait, that's not even factored correctly. Doesn't make sense. It doesn't make sense, absolutely. So for me, like you might think like I'm only target against you, but those Jacob, who started way weaker than you, now is getting 90 on the test. Why? I don't know, because the kids stay after school, they work on things. For you have priority. Priorities, dude, your priority is not straight. I'm gonna say your priority not straight. Your priority, you should get volunteer hour way before senior year. Not supposed to be last year. It doesn't make sense. Your priority is you take 3 days off on Indian New Year. It's supposed to be 2 days. What we agree on, you take it even another day. Priority is not straight. I'm sorry, that's just the way it is.
Because it's all under health management, so I can't really take it.
Well then, dude, that's you have to call in and says I'm not able to make it today. They don't care about volunteer. They care about if you have an hour. Do you have enough hour already? First of all, do you have enough hour already? Huh? You're supposed to get it done way before senior year. You wait till last year to do this kind of stuff, and I have a club, I have things. There's always new things. There was never not saying, and there was no more new things that you have to do. It doesn't make sense that your your operations completely wrong. And just told him, says, look, today I have to make up stuff. I'm sick today. I'm gonna get better. I'm gonna take care of this first. Now, if you says you're gonna treat this as I need to take a test, I need to go home and study the test, and using that as an excuse, that's stupid because you have no Thanksgiving to work on.
Oh, goodness gracious. What's going on? All right. Oh, that is very, I thought that LRAN. Oh, God.
Both you and your parents doesn't have priority right. I'm sorry, but that's just the way it's not. Priority that you should have get help a long time ago. You should stay at the school. You should do all that thing. Therefore, you're not behind today. People way weaker than you, they're coming back. And that's the right thing. They have the right attitude. They say, okay, well, I need to get this settled. But it's not correct to me. That's just not. We give you a phone number a long time ago, too. And you probably have a phone number besides me. You ask people the day before to help. That's not how they work.
It's alright, we got regular decision
Where you going? And even you missed today's test, you still, like, I don't know, if you're gonna treat a priority, whatever, I cannot tell you what to do. But even you missed the test, you still need to go back, because this test is actually to make up the test that you did, is actually a redo of that test. So you just don't have a chance to redo, but you still have to go back. You're making up the making up, which is the chapter 3.